The topic I chose to talk about today is how to use column names as contracts to enforce kind of quality and understanding throughout your data set. And we'll kind of talk first about what this means a little bit more in the conceptual side, then how to do it in R, and then how to do it in yet another tool that I actually think our users probably should also be pretty excited about. But first, let's start at the beginning. Before we think too much about column names at all, the first thing I always like to think about is kind of user interfaces and what makes a good user interface. User interfaces, I think, use a lot of clever techniques to help communicate with the people looking at them. We have the sense of universal symbols, grouping of similar features together. So if I have an up arrow and a down arrow, that probably tells me that those two buttons will do similar things. And hinting with things like aesthetics and colors to help warn you of things like a submit button that you probably should click, or something like red and flashy that you should probably be careful and think critically about before you proceed. Now, what I'd like to argue is that you can actually think about column names as being kind of the user interface of a data set, where they are kind of the only chance we have to communicate with people using that data set what the underlying functionality of the data is. But often, unlike those user interfaces we were talking about a minute ago, these often lack a lot of the really nice aesthetic properties and capabilities to interact and communicate and form contracts with our users. But you could push back on that at first and think, well, honestly, data is just data. What sort of functionality does it have? What do my users really need to know about my data? But I actually think there's a lot of functionality in our data sets that we need to be communicating more effectively with our users. And just thinking about this at a really high level, there are a lot of really subtle design decisions you can think about when you're creating a data set that can really challenge how we do analysis, and then if you're interested in reproducibility, how you reproduce it. So there's a lot of first about thinking about just the origin of every single data point. Where did it come from? When did that field get loaded? What constitutes the unique record? Then we can move on to thinking more about features of the data set and things like how are things encoded? How do we communicate indicators? How do we indicate null values? What is the really specific granular meaning of every variable? And finally, things like usage, avoiding situations like strange timings that lead to feature leakage, weird date formats that break our filters, etc. And if you look on something like Retraction Hub Watch, there's actually a lot of really easy to find examples of how all of these different functionality in our data can actually lead research astray. And that doesn't mean it was exactly a data quality error. That doesn't mean there's something inherently wrong with the data, but a gap and a breakage between how users understood a data point to work and how it actually works can really lead to a lot of challenges. So this is the type of functionality that I think our column names need to better represent in our data sets. So we can start to think about how we would do that, and we can look to popular public data sets to see if they can give us any guidance on this. And what I sort of found when I took a quick survey looking at some of the popular Tidy Tuesday data sets and looking at government data sets is, honestly, I didn't find a lot of really great examples that I really loved about best practices in this area. We can think about data from the US Census Bureau that actually is very, very, very prescriptive, where every single character in a variable name has a very specific meaning. However, when we think about this from the user interface perspective, it still isn't actually very useful because there's really nothing about B01001CE1 that I should inherently be able to look at and intuit that's trying to tell me something about median age. Now, on the other hand of the scale, we have data that tries to be a lot more friendly, tries to be a lot more communicative. And one example of this is from the very popular political science data set that's used to analyze elections of the CCES data. But even this data set, you can see there actually a lot of room for ambiguity, even though it looks friendlier. We could look at fields like gender and age and not know, are those indicators? Are they categorical variables? Are they continuous? We could look at the own home variable versus the has child variable and think, those both seem like they should be indicators, but why are they formatted differently? And even something as simple as like approval rates. We don't know, is that a yes/no question? Is that on a 5-point scale, a 10-point scale? You really have to be very careful when trying to analyze this data set to make sure you were keeping all of that in mind. And not only is this important when you're producing in like kind of situations when you're analyzing data, but I think it becomes even more critical when you're thinking about situations when you're handing off data between any sort of producer and any sort of consumer. Whether again, that's like you sitting in a lab, you as a data engineer, building a data mart for analysts and data scientists, or simply you collecting data and waiting a week or a month before you go and try to analyze that data. So I set out starting to think about how could we create more of a user interface with column names. And ultimately what I settled on was the idea of using more of a controlled vocabulary as a systemic way to think about adding kind of that structure and formalism around names. So next I'll talk in a little more detail about what exactly that means. Essentially, controlled vocabularies are a known concept in the data management space, but more often we think about them as being used for encoding a field versus encoding the names themselves. For example, if I was collecting data on something like, something to do with colors, I might specify a controlled vocabulary of like these accepted values for this field could be like red, blue, and green, but I shouldn't say like some synonym for blue. But what we actually want to do is use a controlled vocabulary to specify stubs, which would help us encode different like semantics of our data set at different levels of granularity. And these stubs can also carry along with them associated performance contracts. And when composed together, as we'll see, they can like start to imbue increasingly like complex concepts about our data. So let's look at one example. And the thing I want to be like really clear about is I'm not suggesting this one example is like how every single person should name their variables. I'm just saying like my argument is only that everyone should have a structure, not that this structure is one size fits all. So we might start out with standardized stubs like ID, ind, bin, n, amount, val, which hopefully you can already start to infer what these mean. But of course, we don't want to make people have to infer, so we can go ahead and define them. So for example, we could use ID to be a unique entity or identifier, n could be a count of some sort of like quantity that we know will be an integer, and we know will kind of be summable. We could use val for values that maybe already have some sort of denominator divided out, so they aren't inherently summable, etc. So you can start to see how our semantics start to bring in a sense of what you are and you aren't allowed to do with these variables. Similarly, if we compare the ind stub and the bin stub, those sound pretty similar. In fact, right now I've defined them as exactly the same. They're both binary 0-1 variables with the rest of the name describing the positive one condition. But the way we can start to differentiate those is not only thinking of stubs as carrying semantics, but is also carrying contracts. So for example, that ind variable might not just mean be a binary variable, but more specifically be a non-null binary variable, whereas bin might be allowed to have nulls. Similarly, we could specify that our date variables or our timestamp variables have certain ISO formats that make them easier to wrangle and use and ensure that they're always comparable. And by sort of defining out this sort of mapping in these sorts of stubs, we could be communicating with users a lot about our data quality and a lot about how they couldn't wrangle it simply by looking at the names themselves. And so on and so forth. We could move into like increasingly higher levels of granularity. For example, now imagine that what the data we're collecting is actually about COVID cases and hospitalizations in different counties in the US. Once again, we could define the stubs to capture entities like county, case, hospitalization. And once again, like at the surface level, those already seem pretty evident what they're doing. And we could go ahead and define those. But I think if we think back on the past year, there are actually a lot of ways that analyzing COVID data could actually be pretty confusing and pretty deceptive at times if you weren't really precise in your semantics, which this approach forces you to be. If we wanted to find a case, we could be motivated to really go into detail and define the lineage and provenance more of that variable when we're defining that stub. And if we aligned on the fact that cases were specifically test confirmed cases aligned by the date of testing, that can help also us better document in a controlled vocabulary, not only the contracts, but also the consequences of some of those things. For example, I think as many of us saw that we're tracking these metrics on a day-to-day basis, the choice of how we're defining the semantics of that variable, of it being aligned by the date of testing, might cause that data to backfill and the kind of values from a week ago to continue to move as more test results get reported over time. So again, this is a very parsimonious way of capturing all of this information in just the word case. So users of our data can keep that in mind whenever they simply see that word come up. And finally, you can imagine going into increasing levels of detail depending on the type of data that is useful in your analysis and the kind of concepts you want to capture, and defining this hierarchy of different stubs at different levels. And then when you compose those, you can create a pretty rich set of variable names simply with these stubs that carry a lot of really specific meanings. So we can think about things like measuring actual and predicted cases and hospitalizations at different lags, different forecasts of periods of time into the future, etc. And really imply quite a lot of useful information just without really having defined 8 or 10 or 12 definitions. And these sorts of techniques that we've talked about map really closely to all the different functionality that we determined earlier was really important to imply when starting out doing an analysis or building a data set for the purposes of sharing. Using things like the entity level to communicate more of the origin, using things like that indicator stub to help people keep track of which case of your indicator is positive, and using things like enforcing a consistent format for date stubs to help facilitate usage. So that's kind of the gist of using controlled vocabularies and the theory behind it. And so next time, hopefully I've intrigued you with the idea, but I want to get a little more tangible where the actual benefits are as we think about kind of all of the users of a data set. I would argue that this approach can help automate data maintenance burdens for data collectors, reduce the cognitive load for data consumers, and add clarity for anyone trying to review a data analysis. And now we'll see specifically as we go through this, how these techniques apply specifically to R. So for the data producer side, this approach can really aid in both data discoverability and documentation. It becomes a lot easier to make data kind of more discoverable and explorable, either in RStudio's great IDE with its variable name completion, or producing some sort of data table in which we can split out those stubs and make data very easy to search for. For example, if we just search on the letter N in this table, we can easily retrieve any of our variables that are count variables. But even more than data discoverability, this approach plays extremely nicely with the point blank package, which is a package I really love to use for documentation. Point blank borrows a lot of semantics from dplyr, such as all of the select helpers like starts with, ends with, contains, and lets us generate all sorts of data quality checks in a really parsimonious way. So for example, here you see on the left, I have maybe only 6 or 7 lines of code, and I can specify the checks I want to do, such as I want like any variable that starts with n as a count, so it should be greater than 0. Any variable that starts with an indicator is binary, so it should not be null, etc. And the beauty of this is you can help create more of a data validation pipeline, which automatically generates the output you see on the right, which performs all these data checks and kind of expands them into a kind of explosion of like every check across every column for which it's relevant. So really nice way to get a more portable solution for data quality management, which with code that you could even import very easily and share between projects. Next up for data wrangling, again, dplyr makes wrangling variables named kind of with a controlled vocabulary very easy with select helpers, and especially after dplyr 1.0 with the across function. So if I want to take the mean of all indicator variables and the sum of any variable containing the stub actual, you can see the code to do this simply by picking those things out, applying the correct selector, and easily letting me obtain summary statistics very easily with code that's very easy to read and follow. And obviously, I think everyone in this crowd, it's fairly safe to assume is an R user, but also want to show, like, although I talk about this a lot in relation to our dplyr semantics, just because it plays especially nice there, but it's pretty easy to do in other languages as well. As you can see on the right is kind of an approach to doing a like similar thing and making use of this naming convention if you're working in a language like Pandas. So, and similarly, just something else I want to call out specifically for kind of dplyr and tidyverse aficionados. One kind of like downside that you might have noticed in the previous example to this approach is when we took the mean of an indicator, it's not really an indicator anymore because it's not 0 or 1. The mean of an indicator is actually a proportion, but dplyr allows us in the across function to use the nice names argument, which lets us rename variables on the fly. So now any variables that used to start with indicator, which got the mean function applied to them, end up in my final data table renamed as prop, for standing for proportion, appropriately enough. The final thing I'll mention, just in sort of pitching this idea, is I also think it becomes increasingly relevant in a world where we're kind of moving beyond tabular data and sometimes working with data without a really super well-defined schema. So as a final example here, I show a JSON blob that can get returned from the GitHub API that represents all of the different pieces of a pull request. And you can imagine if you were trying to wrangle this into a more structured format for analysis, you might run into the challenges of realizing that the word title is used 2 times, the word created at is used 3 times, and the word login is used 6 times, all to refer to the different users that own the repo, own the pull request, reviewed the pull request, the date that the pull request was created versus the date that the repo was created or reviewed, etc. And similarly, JSON is not necessarily known for being great about carrying information along with it about the different types of these variables. They're all strings, which probably isn't how we'd want to leave them for analysis. But I think by applying these same sorts of naming conventions to even our unstructured data, we can still encode some of those same bits of like useful information that we benefit from in a schema-filled world. So hopefully I've like kind of intrigued you that there might be some merit to this underlying idea. But if so, I do also want to call out some of the potential downsides, because the one thing worse than having no contracts with our users at all or having bad contracts and unenforced contracts. We're like, the main benefit of this approach is that it helps us users understand for free so much more about our data. But if we don't actually make sure those things are true in the data itself, we're actually doing harm because we're kind of like lulling people into complacency. So as I thought about this, I kind of identified four main challenges to this approach, which are maintaining a good definition for our controlled vocabulary, then making sure we adhere to those definitions and only use kind of the stubs we've defined, communicating the semantics that are related to those stubs, and finally fulfilling those contracts. So as I thought about can you actually solve these problems in a scalable way, I identified two possible solutions there that I'll demo in the second half of this talk. The first one is an R package that I have on GitHub right now that's still like very much work in progress, but would love any kind of feedback on, and that's called the convo package. And that can be used to define a controlled vocabulary and evaluate it against local data or really any data set that you can connect to with R. The second one I'll talk to after that is a tool called DBT, which is a framework that actually brings a lot of like nice programmatic features into the SQL language, which can be useful if you're working with much larger data sets that maybe you don't want to bring into R to enforce these methods. So let's take these one at a time. First, I'll talk a little about how Convo works overall. At the highest level, Convo allows you to describe a controlled vocabulary with a YAML file. So you can see here on the left, we have a sample YAML file where we define a lot of metadata for each stub, including a stub name, a human readable description, some of the validation contracts we talked about, which are essentially specified as functions that point blank can understand, and any sort of renaming mappings that we'd want to do, similar to the ind versus probe discussion before. And this YAML file can be read into R with a simple read convo function. So when we think about how we can kind of first assess the quality of our vocabulary, I thought about two elements of what it would mean to have a quality vocabulary. First, we want every one meaning, like every stub to have precisely one meaning. Second, we want every meaning to have precisely one step associated to it. So we have functions to help us double check that both of those things are true. For ensuring that one stub only relates to exactly one meaning, we can imagine a case where we might have used the stub cat to mean both cat the animal and cat as in categorical variable, and that's not good. But we can double check this with the pivot convo function, which allows us to return every single level of a controlled vocabulary at which a given stub appears. So by running this function, we can realize that cat shows up both in the first level of our vocabulary and the second, that is like detrimental, probably going to confuse people, and so we can go back and change one of those stubs. Now, the other problem was a little trickier of making sure that one meaning is only associated with one stub, because meanings aren't a well-defined thing. I can't like group by meaning and count it. But one kind of heuristic I relied on when thinking about this is if you end up with multiple stubs that probably kind of were supposed to represent the same thing, what we'll probably find is the stubs themselves are probably similar, although not the same. And I'm sure this is something that many of us have seen variants of in our own data at different points of time, such as a variable account being represented by the word account, the abbreviation ACCT, and the abbreviation ACCNT. So to kind of like leverage this heuristic, the cluster convo function provides a way to apply hierarchical clustering across all of our stubs based on a string distance metric, and kind of quickly and rapidly kind of like group together stubs that are more or less similar. So we can quickly eyeball these and see if there are stubs in our vocabulary that are super similar, and might either like confuse people because they look alike, even if they mean different things, or maybe they mean the same thing and should be grouped together. So if we assume now that we're happy with our overall kind of vocabulary quality, we think it has good properties, we can move on to thinking about how we make sure that all of our variable names actually use that vocabulary. So Convo has some functions for evaluating the names against our vocabulary to ensure that they're matched. So for example, here we have some obviously rather silly column names, but we can use the evaluate convo function to pass in the controlled vocabulary, pass in the relevant names, and find any mismatches of names that violate that vocabulary. So for example, here it's returned that at level 1, we have a violation because XYZ is not in the first level of our vocabulary. In level 2, we find that amount underscore Q violates because Q is not in the second level of the vocabulary, etc. Or alternatively, if we only want the specific stub that violates instead of the whole column name, we can instead use the compare convo function, which lets us do any sort of like set arithmetic, like unions, set diffs, intersections across any two convos. So here on the right-hand side now, we have kind of the cleaned up version of which stubs precisely violated our vocabulary. So I could assess, did I do a bad job naming the variable that contains XYZ and I need to change it? Or is XYZ actually a stub that I really, really care about and need to incorporate in that vocabulary? So can definitely do that either way. So next up, we've confirmed our vocabulary has good properties. We've confirmed that our data set, that the variable names adhere to the vocabulary. Next, we have to check that the data itself actually upholds the contracts that vocabulary promised. And once again, here, the convo package can play very nicely with point blank. The create point blank agent function takes all of the information out of the convo YAML function we decided before, automatically generates the code that creates all those checks, and gives us an object that we can pass directly into the point blank package. Or alternatively, if you do want something that's a little more portable across projects, we can also use the convo YAML function or the convo YAML to generate a YAML file for point blank. So if you recall the initial dictionary we set up many, many slides ago, by simply running the write PB function, we can actually generate a point blank specification also in YAML that encodes all of those column checks and that we could easily lift and shift across projects. So also very handy and will only continue to be enhanced by some of the things I know of that are on the point blank backlog. So very, very excited to keep finding more potential synergies there. Finally, is just a couple of other examples of kind of like things that Convo can do that can be useful. Is we can rapidly split apart all of our variables by stubs, and if we want, even attempt to piece together a human readable description of each variable simply by composing the stub level definitions with a kind of glue string type function. So this can help create data documentation and a very high level data dictionary with pretty low lift of labor. And one step further, obviously, I think a lot of the benefit of this approach is documenting not the data itself, but the dictionary as a whole. So we can also translate the initial YAML specification into dictionary level documentation, including translations of all the point blank checks into human readable English, just for kind of maximum transparency and readability for all users of our data. So that's kind of a survey of where the Convo packages stay. I think there are actually a lot of open questions that I'd just love to like call out here briefly, and would actually kind of like really welcome any feedback on like after the end of this presentation of as I think about kind of what would be the most useful additions to this package. I think some things that I've come up with that I'm thinking about adding in are more alternative ways to specify a convo, such as being able to do it maybe in a spreadsheet. The ability to add more convo level metadata, for example, if you wanted to use different delimiters other than an underscore, increasing vocabulary or increasing flexibility in the convo structure, such as thinking about hierarchical convos that stubs at level 2 can only follow certain stubs at level 1, or adding optional levels then. I think a lot of degrees of freedom you could add, but I'm sure, as we all know, anything that you kind of allow users to specify, definitely a trade-off with kind of like pushing more burden on the users to make all those decisions and make all those specifications. So that's something I continue to work on with this project. Now, the last thing I wanted to talk about is, while I know that we're all obviously here like huge R users, obviously like sometimes we're forced to go outside our bubble, and specifically for data management work, a lot of like data management and data sharing maybe can't always occur in R, which I'll go out on a limb and call for this group our favorite language. But so one alternative tool that I've started using a lot that I actually like, because I think it helps us like use a lot of the same things we all like about R, is DBT. So I want to briefly show how to do some of these same approaches in DBT. Now, essentially what DBT is at a high level is it's a way, if you write any SQL code for use in a relational database, it brings a lot of the nice, more programmatic features of a full-fledged programming language like R to SQL. So some of the things it gives us is more ability to write custom functions with macros, the ability to have templating, such as like for loops and if statements, and kind of a lot of the control flow elements we all benefit by using with Jinja templating, and the ability to more rigorously add testing to our unit testing to our SQL code, the same way that many of us enjoy doing, and kind of get confidence in our code by doing in R. And we can leverage all of these three features to apply kind of a lot of these same nice approaches if we're trying to publish and share data in SQL, in a SQL database, instead of in local flat files. So I'll briefly demo how to use each of these features. First, we'll see how Jinja templating can be used to avoid typos and names. Second, we'll see how macros can be used to operate on column names instead of individual columns. And finally, we'll see how testing can be used to check that we're actually adhering to our contracts. So first up, for Jinja templating, as I mentioned, this gives us more of a sense of control flow, like for loops and if statements. And this can, I think, help really ensure that when we name our variables in SQL, we're actually doing them without error and doing them more precisely. So here you see I've used a for loop to name a whole bunch of variables at different lags, at 7 days, at a 7-day gap, at a 14-day gap, at a 21-day gap, at a 24-day gap, etc. And this can, help me like avoid a case where I accidentally spelled Fred wrong in one of these, or missed an underscore. And I've definitely worked with many a database where that happens, where you have like 20 variables that are similar but not alike. And I think this sort of approach can really help systemize your naming variable names, so you're really adhering to any conventions that you prefer. Now, next up, as I mentioned, I'm a very, very big fan of the dplyr select helpers, starts with, ends with, etc. That I think was like really one of the first things that got me thinking about all sorts of these parts of these topics. But one nice thing about DBT is it does allow you to write custom functions. So I've actually written and published on GitHub a set of DBT macros that borrowed heavily from like the dplyr semantics to give us those same functions, starts with, ends with, contains, everything, etc. So now we can, even when writing SQL-like language, collect all of my variables in this table that starts with the letter N, and then use another macro to apply a casting function to cast all of those variables to the right data type. I specified in my semantics that all N variables should be integers, so I can go ahead and cast that variable to an integer in my select statement. And with this kind of raw template code, I can simply run the dbt compile function and compile this to a nice SQL script that does all of my variable casting to ensure that those promises are kept. But finally, even if we think we're keeping our promises, it never hurts to test. And with DBT, we can test at any point in a SQL pipeline. And specifically, you can think, well, you just cast something to an int. So if you check if it's an int, it's going to be an int. But how do you know that you didn't just coerce a like float into an int or something else that probably would have negative consequences? So what we could do with DBT is set up a test that would test that before we did any of this casting work, that for every single variable that starts with n, using that same logic as before to get those variables, that there's no functional difference in absolute value between the cast value of the variable and the raw value of the variable, which would give us more confidence that we didn't actually break anything or do anything bad by doing that operation and trying to uphold our contract. And once again, the contract, the kind of the combination of DBT's testing features that we're specifying and the Ginger templating allows us to rapidly generate this test for the 12 or so relevant variables in our data set. And we can kind of then just have confidence that that will run every time our data set is recreated and allow us to continue to maintain our contracts. So kind of in summary, and to like start wrapping up here, data is like very complex and has a lot of like complex, like very nuanced functionality. So when we think about handing this off to users, just like none of the developers of our favorite applications would hand us just the raw source code of that application, I think it's also incumbent on us to build some of these nice semantics and aesthetics and the sense of a user interface on top of any data with which we hope to work with someone else. So ways we can do this are leveraging unique symbols, such as the stub names that we talked about, using kind of grouping, which we kind of get for free when we have like stubs kind of like grouped together and benefit from things like autocomplete. And finally, when we use kind of the semantics to hint at aesthetic properties. So someone might see a bin variable and immediately have that red flashing button in their mind that, hey, wasn't bin the one that does allow nulls? I'd better check out this column in more detail. So with these simple principles, I really hope that we can make better kind of user interfaces and user experiences for our data users, whether that be someone we're collaborating with or even ourselves. And this is definitely something I've spent far too much time thinking about and playing around with over the past few months. And if anyone's interested in learning more or kind of just exploring what I have out there, just I'll briefly call out, I have a couple of blog posts on this, both the R package itself, as well as how it interacts with DBT. And definitely am very curious to hear kind of other people's like thoughts, experiences, and feedbacks kind of on the whole kind of approach. So yeah, thank you. With that, I will stop sharing and happy to take any questions and or discussion.